All right. Okay, so we're going to move into chapter 8 this week. We're going to look at the law of sines and the law of cosines. So far, we've talked about some basic right angle trigonometry. Did sine, cosine, tangent. SOHCAHTOA, you can figure out with Pythagorean theorem and those type of things, the sides of a triangle. We did all the wonderful trig identities and stuff like that. We were looking at the unit circle and saw how things became more rotational. However, we do have a lot of right triangles and we can make things into right triangles, but not all triangles are right triangles. So we still need to have some way to be able to find information about those triangles that use trigonometry. Since we have them that we can do any angle with it, we can still use trigonometry for it. So the first thing we're going to look at is what's known as the law of sines. So the law of sines is three ratios. And it can be either direction. I typically write the sign on top, but you can write the sign on the bottom as well. It doesn't make a difference. The key is that the ratios have to be the same. So basically the ratio is the sine of the angle to the side that is opposite of it. So when you're setting up your triangle, the larger letters are your angles, and they are opposite the smaller letter, which is the side. So angle A is opposite of side A. Same thing with angle B is opposite of B. Angle C is opposite of C. In a regular right triangle, the only one that truly mattered was C. That was your hypotenuse. A and B didn't really make much difference because they were opposites of each other when you were lining them up. But C was always your right angle, and that was always opposite of your hypotenuse, which was C side. So you can start to look at how the larger the angle goes with the largest side, as in your triangle. Same thing actually with this. The angles, the ratios are going to set up. So the bigger the angle, the bigger the side that's going to be opposite of that one. So can we figure out angle B real quick?
Yes.
What's angle B? 60 degrees. Okay. That's what I want to do. That's what I want to do. So angle B is 60 degrees. So what's the largest side? C. What's the smallest side? A. Okay, so just by knowing the angles, I can figure out the order of the sides. Now, using the law of sines, I can actually find all those sides. So when I'm setting these up, again, my little thing is try to use what they give you more than what you found. Because once you find something, if you made a mistake there, you're going to make your mistake in all of them. So they gave me these three pieces of information. Okay. They actually did not give me a pair, but I'm going to assume you can do your simple calculations correctly. So we can use the 60 as my pair. So we're going to use the B's as the pair of information that I'm going to use for the ratios. You need to have one complete ratio and then one other piece to find it. So whenever you're setting up your equation, you need three of the four things. Yes. How many degrees are in a triangle? That's okay. 180. So we just subtracted the other two from 180. I didn't do it. I'm assuming they got the 60 correct. Sometimes I just have to go with you. All right. So we're going to use the B. So we have sine of B over B.
So will we always need a side?
Yes, you always need at least one side and a pair. So you have to have a side and an angle that goes with it. So you can do this with two sides and an angle. You can do it with two angles and a side. So you need to have a pair. So do it. Okay. So if you don't have both angles, you need to have the angle that's opposite of one of the sides they gave you. Right. So we were using, but they were right triangles. So technically, when we were looking at that, so if you look at just a right triangle, so I gave you like that was 60, and we were looking for that side there. We had two angles. You never really look at that angle because it's there and it's a 90 degrees, but technically we have those two angles and we have a pair. So it's like so that's the pair that we're looking at. The nice thing is because it's a right angle, we can use the Pythagorean theorem, we can use those right angle trig functions, those to do it. So it makes it a lot easier than having to do with the law of sines. All right, so sine of 60 over b, which is 4. So now let's figure out which side do we want to find first, A or C? All right, so let's find A. So we're going to use sine of A, which is 48, over A. All right, how do I solve fractions across an equal sign? Cross multiply. So I have A sine of 60 equals 4 sine of 48. And how do I get rid of I wanted the A by itself? Divided by the sine of 60. So I have A is 4 sine of 48 over sine of 60. Notice I have not done any of those calculations yet. Don't do them until you're at your final answer and plug the whole entire thing into the calculator at once. This way you've got an exact answer. You're not rounding before you get there. Now let's use Desmos. So 4. I know you can't see them. I'll switch over in a second. So we've got, my answer is 3.43. Now, is my calculator in the correct setting? Yes, these are degrees. So you can see if I was in radians, I get a different answer. Make sure you're in the right setting. Whenever we're dealing with triangles, 99% of the time it's going to be in degrees. So just look at that. If it's not, they'll have to tell you, obviously. But 48 radians wouldn't make much sense in a triangle. So we've now got A. A is 3.43. That's the side. All right, so we have A. We still need to find C. How? How? Okay. Could use the law of sines, but I'm going to guess that's not what somebody wanted to try. Which one? No. At least nobody actually said it. I was kind of expecting it. We can't use the Pythagorean theorem. Which normally is what somebody wants to try here. Oh, I got two sides of the triangle. Why can't I use the Pythagorean theorem? I don't have a right triangle. Okay? It's not a right triangle. Now, I don't want to use the 3.43 because I found it. And it's rounded. Okay? So because if I need to, there are certain situations where you're going to run into that situation where you're going to need to do it. But in this situation, I don't. I still have a pair, and I can use my other information to find C. So I'm not going to use the 3.43. I'm going to use the other information I have to find C. Okay. All right. So we're still going to use B. So I still have the sine of 60. If you use the 3.43? Yeah. Possibly. It depends on how particular Alex wants to be. And I'm not quite sure Normally they tell you don't round until you get your final answer. So it could be very like close. And when we're looking at 3.43, if you want, they want 1 decimal place, I think, on theirs. So if you had gone 3 decimal places and used that, you'd probably be fine. Your first decimal place would be right. But I'm one of those ones that if you don't have to, why risk it? And also, if say you screwed that up and used radians and you got 10 point something, and then you use it, you're guaranteed to get C wrong. All right. So if we don't use the stuff we found, we have a possibility of getting C right and B wrong. And that also can, the next piece I'm going to show you after I get this answer is when we're going to check the work, that might help me figure out, wait, something's wrong here. And that'll catch a mistake, where if we use that number, we might not catch that mistake. So we got sine of 60 over 4. We're now looking for C. So which angle am I using? 72. So we have sine of 72 over C. Same concept, cross multiply. So C sine 60 equals 4 sine 72. So C equals 4 sine 72 over sine of 60. Go back to Desmos. And we get 4.39 for this one. All right, what did I tell you about the relationship between the angles and the sides? Huh? I still didn't catch what you said. Yes, they should make sense. So which side did we say was the biggest? C. Is C the biggest side? Okay, which side was the smallest? A. Is A the smallest side? Yes. Use that. Because if you screw up, a lot of times, that's not going to work. And that'll catch a mistake before you make it. Okay? Also, the closer the angles are together, the closer the sides are going to be. If all 3 angles are the exact same, they'd be what? They'd all be 60 degrees, right? They'd all be equal. An equilateral triangle has equal angles and equal sides. So 72 and 60, 72 and 48, like these are further away than those. That's going to be further from that than that. It's like you can start to use that to get a general idea of what's going on to make sure your answers make sense for the problem. Okay, it's not going to be exact because it is a ratio, but it's a good quick estimate of saying, okay, this answer makes sense. Let's put it in, right? Especially on Alex, when you have one shot, you type it in, it tells you if it's right or wrong. It's like, want to get it right the first time. So this way you don't lose the points. All right. I want one. Oh, I'm looking for another one that gives me 2 sides. 2 sides. Forget it. I'll just make one up. Also, never go by the look of the triangle. All right?
Does that mean it's not to scale?
It's not to scale and might not even look right. Like, literally go by the information they gave you. For example, I'm scaling this triangle. The numbers might not make sense for the picture that it looks like. That's fine. It's the information that's there. The ratios will still be the same. The sides across the things will be the same. I just wanted one with 2 sides instead of 2 angles this time. So we're going to make A equal to 12, B equal to 14, and angle A equal to, let's make it 48 degrees. All right. Pictures do help, especially when you're looking for connections. So let's put the information on the right things. The labeling does not matter. You can label your side angles anything you want. The angles have to be across from the same side, though. So pick which one you want to label first, and then label your angles the same or vice versa. So we've got A is 12, B is 14, and angle A is 48. Before we can do anything, we need a pair. Do I have a pair in this problem? What pair do I have? I have A's. Good. So we can use that as my initial thing. Okay. So I have sine of 48 over 12. All right. So what's the next thing I need to find? Why can I find B? Right. I need one other piece of information. So right now, C, I have nothing. So I would have ended up having sine C over C, and I'd be stuck. So I need to have one other piece of information. I do for the B, so let's use the B. So I have sine of B over 14. All right. How do I solve this one? Same concept, cross multiply. Actually, in this one, I'm not going to do a complete cross multiplication. Because if I just multiply the 14, I now have sine of B by itself. So there's no point in multiplying by 12, because then I'm going to have to divide by 12 anyway to get the sine of B by itself. So here's the question. How do I get B? I'm going to use the inverse. I'm going to use the arc sine. So I have sine -1 of 14 sine 48 over 12. That's fine. So when you put it in Desmos, again, type the entire thing in. All right. Don't try to do the pieces. And you can do the same thing on your graphing calculator. Your regular scientific calculator, depending on how, if you can see what you're typing in, it'll be easy. If not, it'll probably be a pain. At that point, do the inside first, get that answer, and then you can do the arc sine of that function. So that's why I like Desmos. You can actually see exactly what you're typing in to make sure you typed it in correctly with the parentheses and stuff, because otherwise it can get messy. All right, so I have 60.11 for B. That's the angle. All right. I now have that. Okay. How am I going to find C? Yeah. In this case, the only way that we can do this is we have to use the information we've found. Okay. I have to subtract it from the 180 in that situation. So what's C going to be? Okay. Actually, it's pretty close to that one. And I just randomly picked numbers. All right. So find me C. I found a trick on how to do it on the computer. You hold shift while you're drawing your lines, it'll make it straight. But it wouldn't work on a tab. All right, so what did we get? Yeah. 15.35. All right. So, does it make sense? Biggest angle, biggest side. Smallest angle, smallest side. So, yeah. That works. All right. Get to another one. This is going to give me the thing I want. Perfect. We've got all right, so we've got A is 37, B is 45, and A is 29. All right. Do I have a pair? Okay. Which thing can we find right now? B. All right, so find me B.
So there we get letters like text or anything.
Technically, the letters don't matter. You can use any letters you want. When it's just a simple problem like this, you're typically going to see A, B, and C. The only time when you're going to see different letters and stuff like that would be if it was a work problem or an application problem. And then you'd want letters that kind of make sense for the problem, like the length across the water or this brick name. Those type of things. Yeah. Oh wait, that because the side's 45, not the angle. All right, most people seem to be getting this one. All right, so we ended up getting, instead of writing it all down. Yeah. The B is about 36.13. All right. Let's see. Well, I can't find the side yet. I need to find the angle. What's the angle? Huh? How'd you get 14? Oh, 114. That sounds better. I'm like, how'd you get 14? What was it? 114 point what? 87. All right. See, remember how I told you don't look at the triangles for your information because that's nowhere near an obtuse angle? Okay. Here's where we can run into a problem. Remember sine, okay, on the unit circle. Where is sine positive? In the first quadrant. Where else? In the second quadrant. What are the degrees that I could possibly get on a triangle? 0 to 180, right? That means the first quadrant and the second quadrant could both work. Your calculator will only ever give you one answer. Okay? Because the calculator is always only going to give you one. And it's always going to give you the one in the first quadrant. All right? So, what we have is we have a situation where we could have multiple correct answers. So if we look here, you can see how that 0.5896, the actual value that you got when you plugged it inside the thing, has two possible values that would work. We've got this one, the one you found, that's the 3613. But we also have this one over here. So looking at our unit circle, this is 3613, right? What's this stuff over here then? That's also, right? So to find this one, we would do 180 minus that. So it's 180 minus 3613. $143.87. Now the question is can that angle work? So the reason we would have had to do the exact same thing in this one, except the other angle based on the angles we had wouldn't have worked. So we have to look and see, will it work in this one? If stop switching back and forth. Okay. If I make B 143.87, can I still find a C that's between 0 and 180? Okay, what's C going to be? So add B and A and subtract from 180, right? And what do I get? $7.13. That works. That can happen. Okay, so I have two possible triangles that'll work. Okay, this only comes up when you have side-side angle. Okay, when you're given the two sides and the angle that's outside. So basically the angle that's the opposite. If I gave you two angles, there's only ever going to be one other angle that'll work. Okay, but this can happen when I'm giving you two sides and only one angle. We can have multiple possible situations that can work. Yes, you will need both of them. Okay. So does that make sense on how it happened? Okay. So when you're given a triangle where you're given two sides and an angle and you're looking for that angle, when you're doing the arc sine, you have to check and see if there's a possible another angle that would work. So if we go back, let's look at this one here. So we figured out that B was 6111, right? Okay. If I had subtracted that from 180, I'd have gotten, I'm watching, this one actually comes out to be another triangle that I didn't actually catch. So if we subtract that, we would have gotten, what, 119 point, and actually it does. This is what happens when I make up problems in class off the top of my head. 119.89. It will. If we find out the actual 119.89 plus 48, 167. So yes, he would have worked out to be that one too. Of course it would have. 12.11. So yeah, I would have had two triangles for that one too. Don't make up triangles off the top of my head. That's the rule I'm going to find out now out of this problem. So I would have got the answer that I got was right. There's just a second triangle that it would have worked, and that's what we're going to do in the next one here. This is what happens, like I said, when I make up a problem. Sometimes it doesn't work out the way that I thought it was going to. It's okay. All right. So let's finish this one. We'll come up with both answers for it. So let's do the block part first. So we've got the 3613 here and the 114.87 over there. So how would I find C now? So I have to do the law of sines, that ratio again. We're going to use both the A's because I have those both. So we have sine of 29 over 37 equals sine of this over here. Put that out of the way. We're doing C, so 114.87 over C. Cross multiply and solve. We have sine 14.87. So I have 69.24. So C in this case is 69.24. All right, does that answer make sense? Yeah, if we're looking at the biggest angle is 114.87, right? The biggest side is 69.24, and that's significantly bigger than the other two sides. The small side is 37, and the smallest angle is 29. So that kind of makes sense. All right. Now we're going to do the exact same thing, except I'm going to use the 713. So we do sine of 29 over 37 equals sine of 713 over C.
A regular question says that would act for both.
So here's, I'll show you. This is how the question shows up in Atlas. They're not going to tell you necessarily it's going to have both. And I'll tell you right now, in the test, it's not going to tell you you're going to have both. It's just going to give you a triangle. So you have to look at it and say, okay, if it comes up to be a side-side angle, like we just had, you have to know that there is a possibility of two triangles that would work. So we have to check that. Okay. It's always a possibility. Doesn't always happen, but it is a possibility. It really depends on the angles that come out and the sides. Because if you take those two angles that you get, so the angle they gave you and the angle you first find, if it's over 180 to begin with, you know there's not going to be another one that would work. Because it's just, you couldn't add them up to get to the 180. That's the key. The three angles have to add up to the 180 degrees. So you kind of have to do that little check at the beginning just to see if you have a second. Okay. And it's only going to come up when you have those two sides and the angle. If you have two angles, it's never going to come up because the third one's automatically given to you.
Yeah.
So, okay. So then my two answers would be the red ones, because you're only giving the answers that they're the ones that they're asking you to find, and then the black answers. Those would be the two different answers that you'd have, and you'd have to write them both in the question. Okay. Does that make sense? All right, let's see if I can find one that's not going to have it, but I want you to see it. Try another one. This is me not coming up with a problem off the top of my head. And of course, everyone's going to come up to me one, so they're going to make me come up with another one. Okay. All right, let's look at this one. All right, set this one up. Okay, so we got two answers for B. 2940 or 150.6. So everybody should have gotten 2940 with the calculator. So how did I get the 150.60? Just subtracted it from 180. Now, the 2940, that's probably good. That's going to work. I can still get a number for C. If I made B 150, what's 150 plus 40? 190. I'm already over 180, right? So that one's not working. Okay, so I don't need to use that one. All right, that's the check. Basically, just add it to A. If you can still subtract from 180, you have two answers. If you can't, then you only have that one answer. All right. Yeah, because it's always going to be in that first quadrant piece. So you're always going to get one. That answer is always going to work. It's the second answer that might not work, because that's the one where you're over that 90 degrees, and that's where you start to run into the problems. So then we can use that one to find C, which was 119. No, wait. 110. Thank you.
Also, definitely not to scale.
Oh, no. Yeah, that's what I'm saying. Never look at it as, oh, this doesn't make sense because of the picture. Don't ever do that. And I don't think Alex actually says not drawn to scale, which it probably should. Oh, yeah, it does say the figure's not drawn to scale. Okay, good. Yeah, never, ever, unless it's, I would always go, unless it says the figure is drawn to scale, assume it's not. Okay? Math people are lazy, and we're just going to draw the simplest shape we can find to make it, and just go with it.
Numbers,
yeah.
Worry about the size or shape.
And basically, yeah, we're just making up the numbers for the problem. It doesn't make a difference.
Logic, they just think about math.
Pretty much. All right, let's see.
In high school.
So we got sine of 110.6 over, because these aren't always designed to be realistic. And that's the key. These are just problems. We'll do a word problem in a minute. We got 80.09. Uh, 80.09. Yes. Right, you can't find a second C because second C doesn't exist. Remember, a triangle has to have 180 degrees. So if B was 150 and A was 40, we're already at 190. There's no angle left for C. So. It's two kids standing on opposite side of the lake from their house.
Oh, they're sledding. That's water, not snow.
That's water.
I thought they were
There's a word problem that goes with it. I just didn't copy it. It says Gordon and Carmen are standing on a riverbank 120 meters apart at points A and B, respectively. They want to know the distance from Carmen to the house located across at point C. So Carmen is B. The one nice thing about, well, the one really nice thing about word problems typically is they will only typically ask you for one piece of information. So you don't have to find all three like we were just doing in the other problems. You just find the piece that they want. In this case, they're looking for the distance between Carmen, that's Carmen, and the house. So we're looking for that. Okay. So how do I find it? Okay, so I don't have a pair currently. I need to find a pair. So good. I need to find the angle of C. So what is angle C going to be? Was it? 50. No, yeah, 58. 58. So that's 58. So now we have a pair, right? No, reverse. Right. Remember, it's always the angle. And we're looking for the distance from Carmen to the house, which is actually side A. We're looking for this right here. So this is actually where one of those things that you can easily get confused. Because like, okay, I'm looking for Carmen. I'm going to use angle 70. Right. So that's where the drawing of the picture, the nice thing is they give you a picture so you don't necessarily have to draw it. So using that picture really helps. I'm looking for this side here. The angle opposite of it is the angle that is at Gordon, not Carmen. So I'm using the angle of 52. So I have sine of 52 over A, which is the side that I'm looking for. So we can do our little cross multiplication there and solve. So we have sine of 2, sine of 58. And we get 111.5.
Where did I said the letter
Right.
Oh, what, capitals and small? It really comes up in the geometry, like the triangles, polygons, and stuff like that. We always use the capitals to represent the angles and the lowercase to represent the sides. And the only reason they really do that is for things like this, is because you want the ratio of the letters to go together. And if we use different letters, it would make the ratios really hard to remember. So by using the same letters, correct, using the same letters kind of really helps with that situation.
So they could ask it find A or find B and C.
They could technically ask any of it. They could ask you the angle, they could ask you the sides, depending on what they're looking at. But they typically will only ask for one piece of information. That's one of the nice things about these word problems. How far are the boats apart?
So we know something else.
No, you're gonna have to do some math. We're obviously using the law of sine. Because I haven't talked to anything else yet. Now we're going to see how much you remember of geometry.
Very good. That's the piece most people have to cover.
I've done this a few times.
I'll give you a hint. You have to assume the lines are parallel. The plane and the water.
Oh, so that means.
I tried it. Let's have something. Yeah.
I missed that. I did.
Does it not?
I was missing the 3 miles, right? I do. Where did I? Because I thought it was.
No, you're right, never mind.
Okay. I at least remembered that.
Alternate.
Does it not make sense at 46, 56, 55, 8?
Yes, that's how you're gonna get the angle of lift. That is correct.
Oh, okay.
But you need them for another piece.
That, okay.
Huh? I still need a pair. I need this one.
I mean, so like, because of the way they would work. Also, do 180.
Well, 180 will give me this one. Oh, yeah, if you already had these,
Yeah.
then yes. The problem is most people are gonna look at, oh, okay, I can figure that one out easy. 180. The piece that you had to remember from your geometry class was alternate interior angles. So that angle of 46 is that angle of 46. That's the piece you had to remember. So alternate interior angles. And then the 56 and the 56. And this was what, 78?
Yeah.
So now we have the pairs. So that's little b, and we're looking, so we'll make that, that's A and B, so we'll make that C, so we're looking for little c.
It was opposite angles.
You literally have to look at it as, you have to ignore this line first, and that information over there, just ignore all that. That's the line, that's your transversal, and those are your things. So that's why the 46 and the 46 go there. And then do the exact same thing for the other side. Ignore the other side, and you have your transversal. So we've got sine of 56 over 3. Sine of 78 over C.
Next step up. 46.
So yeah, 3.5. 3.5 miles.
Basically, like.
Yeah, so you got to remember the concept of the transversals. So if we have that and that line there, that's what you're looking at, is just that piece. Ignore the other angle on the other side. So that's 46, that's 46. And then you have to do the other transversal, ignoring the 46 side to get the right size. So. All right, let's do one more word problem.
So if it were to be like figure eight scale, you wouldn't need any of that information, right? You could just put 78 into 180 minus 78. That's the 78.
No, that would, you're not saying it's drawn a scale. You're saying that at that point they'd be equal.
Yeah.
And they would have to have told you that. So if they said that side's 3 and that side's 3, then yes, you could assume those two angles are equal to each other. But since they only gave you one of those, you can't make the assumption that the other one's going to be there. Yes.
I had accidentally swapped the 78 to 102. Like I had added the 46 and the 56 together, and I accidentally used that instead of 78. And I still got the same answer. Does that correlate with the?
So you added them and got 102, and you still got the same
46
answer?
and 50, yeah, it gave me the same answer on the calculator.
But you used 102 for the top?
I used the 102 for the top. So it was like.
So you did sine of 102 over 3?
3 sine of 102 over sine of 56. Yeah. So yeah.
I think it's a rounding. Yeah, I think because of the rounding it worked out. That will not always work. And happened to be because they were close enough in the rounding to make it work that way. Yes.
It's the same exact number. It's really the same exact number. I was like wondering if that was because of the unit circle thing.
Yeah, but 102 wouldn't make sense there in the triangle.
But it would make.
Oh,
sense.
you know why? Because you're not using this one. So since you don't know this side, that's why.
Oh, okay.
I'm sorry.
Sounds fine.
Yeah, because you're not using this angle at all. So technically this side, when you got it, would have been shorter, but it didn't make a difference because we didn't care about that side. That's why it ended up working out that way. Luckily, not always going to be happening. Okay, is Omar going to get hit by the tree?
Yes. It may maybe end up in the hospital.
We'll figure it out. So I will tell you right out. So this actually is a situation that I had to do. So one of my friends who is an Army helicopter pilot was trying to cut down a tree in his backyard. And he needed to figure out exactly how high up the tree he needed to cut it so it didn't hit his house, his neighbor's house, or the fence. So he gave me all these distances, and basically I had to do exactly this in 3 dimensions in the back of his yard to figure out how high up the tree he had to cut. So then it fell, it didn't hit his house. We got the top of the tree. I was 6 inches from his house when it landed.
Oh, that's not 90.
No, what?
I did that too. So that's not right.
It was 90 to be way too simple. Quick Pythagorean derby, be done. Yes. However, we're talking about the law of sines. Therefore, it's not going to be that simple.
Is this like law of cosine?
No, you don't need the law of cosines for this. This is the law of sines.
Well, I know. But
We are going to do law of cosines in 1 second. That's the next problem I'm going to do.
so there's laws for all of them.
No, there's only law of sines and law of cosines. So do I need to find anything before I do this problem?
Yeah, the other angle.
I need the other angle because I need that pair. Okay. So it's going to be what? 60. All right, so I've got x over the sine of 60 equals 74 over the sine of 33. This is the first time I actually wrote it the opposite direction. Remember, you can write the fractions either way as long as they're both flipped. It's fine. It's no different. There's a lot of times people want to always put the one they're looking for on top. So it doesn't make a difference. It really, truly doesn't. And honestly, I've been consistent and I literally just forgot when I wrote this one down. That's why I flipped it over. But it doesn't make a difference. It really doesn't. Yeah, and then you'd have sine of 60 over x. That they're exactly the same thing. Remember, as long as I flip both fractions, nothing's changed. That's fine. You're fine. Like I said, it's a lot of people always try to put the things on top. That's why when I wrote it, I'm like, oh, I really have to say that. So we have 74 sine of 60 divided by. And it doesn't change the work. Like when you type it in, it's going to be the exact same thing. So 117.7. So the tree will not hit Omar. Yes. Yes. So yes, it will definitely be bigger at that point. Except the question really didn't ask if the tree was going to hit Omar. The question really asked how far Omar was from the tree. I just figured that was a quick, easy way to ask the question to figure out how far the distance was. So, and if you were standing there, that's the question you were going to ask yourself: is this tree going to hit me? You wouldn't get hit. No, the tree's only 74 feet high.
Yeah, I was joking when I said yes.
Yeah, the tree's only 74 feet high, so you're fine. Doesn't make a difference in this situation. If Omar was laying down, then it would make a difference. Sure, that also helps. It's like we say when you're chasing a bear. So if the bear's chasing you, you don't have to beat the bear. You just have to beat the other person with you. All right. So every single problem we've done so far, we've had to have what before we started the problem? We need a pair. Not necessarily two angles. We need a pair, right? We need the angle and the side that goes with it. What happens if I don't have a pair and I can't make it? And the math says, sorry, can't do this problem. Try again later. No. You have way too little faith in math. Mathematicians goes, ooh, that's a problem. I got to figure out a way to solve this. All right. So if I give you two angles, you can always find the third angle, right? So we will always, as long as you have two angles and a side, you're always going to have a pair. If I have an angle and the two sides that go around it, I also am going to have a pair in that situation because one of the angles will be opposite of the pair. The situation where I'm not going to be able to find a pair is when I have side angle side. So we have this one. So I have two sides and one angle, but the angle is the angle is between those two sides. That's the key. So in this situation, I have 56 here, I have 50 here, and I have 98 degrees here. So there's no way for me to make a pair because I can't use the two sides to find the third side. I don't have two angles to find the third angle. Okay, so to do this, we need to use what's known as the law of cosines. They had a lot of time on their hands. As I was telling one of the students before, a lot of the stuff that we do is because before we didn't have computers and calculators and a lot of those other things to figure things out. So even back in the Greek times, they needed to figure out how far rocks were going to fall from a trebuchet and things like that, or how far an archer's arrow would fly. So they needed to be able to do those calculations. They didn't have a calculator. So they needed to be able to figure out that stuff manually. So they did a ton of work with triangles and stuff to be able to figure out those opposite sides and angles and stuff like that. So once they figured out the trig functions, they started being able to figure out that it's a ratio. So then they were like, okay, there's connections between those ratios. And if you look at this one, it really looks like the Pythagorean theorem. So this one really played into the Pythagorean theorem. So there's 3 of them. Believe it or not, you really don't have to memorize all 3. They follow a pattern. The side you're looking for is the cosine of that angle. Those are the same. So see a squared, b squared, b, c squared, c. The letters next to them are the ones that you have. So if this is A, you have to have B and C over here. If this is B, you have to have T and C. If it's C, you have to have A and B. So if you remember one and like the pattern, you can do it for any of them. That's make a difference.
It's kind of like the truth, so.
Kind of, yeah. You kind of have to remember that the concept behind it and not necessarily memorize all 3 problems. All right, so we've got this, right? What do you want to find? Okay. So when we're depending on what we want to find, depends on which one we're going to use. But we also have to make sure we have the right information for it. Okay. The goal is to do what though? We want a pair. Because once I get a pair, I can do the law of sines and make my life easier. All right. We want a pair. So I either have to, in this case, any of the 3 that I find will give me a pair. So if we look, let's look at C. If I look at C, I'm using this equation right here, right? Do I have A and B? And do I have angle C? Yes. So I can use that one. Okay. So just to explain, let's say I wanted to find angle A. I would use this one, correct? Do I have side A? Yes. Do I have side B and C? No.
So you have to solve.
So I can't.
So you get that pair.
Right, but then I also don't have that. So I don't have any of that. So I can't do that problem because I have 2 unknowns.
But once you have.
Once I have one, I could use it. Yes. Correct. You are not going to have to use the law of sines more or law of cosines more than once. You get a pair, then we can use the law of sines. So I've got c squared equals 56 squared plus 50 squared minus 2 times 56 times 50 cosine of 98. How do I get rid of the square? So in essence, to find C, I'm going to do the square root of that whole thing. So now I can just type the entire thing right into Desmos.
What if you just completely square?
You still have to square root it. You can't take the square away from each of the pieces. It doesn't work that way. Oh yeah, you could do all the math out and then take the square root of it. Yeah. You can do the problem out and then do the square root. But you can't just eliminate that square and go, oh, I can take those squares away over there.
Well, yeah,
Can't do that.
but I don't know. I would think it just straight up automatically put in a square.
Yeah, that's what I just did. That's literally how I did it. I just did the whole thing under the square root. Or you could just do this part here and then take the square root of that answer. It'll also give you the answer. So either way, it'll work. So we've got 80. Let me see what Alex wants the answer as. They want it to the nearest tenth. So yeah, that'd be 80.1. But here's the problem. what is it, 80.0960, 80.0960. All right. So C, when you got it, when you rounded it, it's 80.1. However, I need to use that to find A and B. Okay. So I don't want to use 80.1 when I do my calculation for the law of sines. I want to use either the entire number or at least 4 decimal places of it. Okay. And actually, that's what Alex tells you. Alex says round it, use the intermediate calculations to at least 4 decimal places. So this is one of those situations where you need to use what you found to find the other information. So. Duplicate this.
Would you ever give us like a time that fraction?
You could. It could be a decimal. I'm going to pull it right from, I'm going to, like, I make the test right from Alex. So it's like, I don't think Alex typically does them as fractions. So, but it can happen. So it's like, I'm not necessarily saying it's not going to be a decimal on the test. It's not going to be 2.5 though. It'd be because most of the times when you're doing realistic style problems, even like the word problems and stuff like that, you typically don't write them as fractions. You're going to write them as decimals. So that's where they're going to show up. All right, so now we can do our sine of 98 over 80.1 equals, which one do you want to find first? The sine of A over 56. And actually, I don't want to use that. What was it 0960? 0960. So yeah, you really like you only want to use a lot of cosines once, and then you got your fix. Life a lot easier.
Yeah.
Oh, I would be. I don't know if that'll work. I don't think that'll work. I like what you did, but I don't think that's what's like that. And actually, here's the thing: never use E. E is a number. It might have worked if you use like A or something, but I'm wondering if when you put E in, it's looking at it as 2 points and it's not. Yeah. So try switching the letter and see if that works. If you're using the scientific calculator, there's actually a button on it, answer. It'll transfer the answer for you. So they got 43.8. Yeah. So in this case, I got 43.8. And now I can find B just by subtracting from the 180. So is it? 38.2. Yep. Let's do. Yeah, just do the opposite direction. Yeah. All right. The boat travels from port A to port B, following this path. If it wanted to go directly there, what angle should it have gone at? So we're looking for that. We're looking for the angle A, yeah. Yep.
And port A and line of each other, like that straight line.
Yes, it is a straight line.
It is a straight line.
Yeah, my line's a little off, but it is. It does not make a 90-degree angle.
And the sides.
That's right.
So that's the length. Yeah.
All right, so what's step one?
Find angle.
All right, so yes, the very first thing, before you can do anything, you need to find angle 6. Yes. So before you can do anything, we need an angle inside the triangle.
Yeah.
Which we don't have currently. So that's step one. So we got that there. Okay. Once we've got that, we can do what? Now we're going to need to use the live cosines, correct? Because we do not have a pair, and I need a pair. That's right. Yeah, that's right for C. Okay. Is there another answer that would work? Remember, whenever I have side-side angle, which in this case I do, you could possibly have two. You have the right answer, but just keep that in mind. Huh? Yeah. Okay. You can have another angle, yes. Yeah. Because it's side-side angle, you can have that possibility. All right, so that's the law of cosines part. So we know this side is 169.0 or 0.1 actually, for just rounds. Now I have a pair, right? So we can do the law of cos or law of sines at this point. We get A is that. You could get the other angle. The other angle would be 135 degrees, right? Does that angle make sense for this problem? No. Did you even have to do that before you look, just by looking at this triangle? What piece of information would give you that would say you don't even have to look at that part?
Circle for the line.
Don't ever go by the picture. What information? Why? How many? A triangle can only ever have one obtuse angle. So 111 works there. There's no way that I could have another angle that would be obtuse for A. So the only one that would work in this case would be the 44.5. Okay. And we know from the sides that C has to be the biggest angle anyway. So we can even look at that part. So A can't be bigger than C in this situation because it was a smaller side. So they would have to go at 44 degrees. Or actually 44.5332 degrees, because if you're off by a tenth or a hundredth of a degree in the middle of the ocean, you could be far off of where you're going to get to at the end. So this is why, if you remember back at the very beginning, when we first started talking about, one of the things we talked about was degrees, minutes, and seconds. Navigation typically uses degrees, minutes, and seconds because it gets a very precise place on it. So your boats and stuff like that would not use decimals. They would use degrees, minutes, and seconds. And things would be in nautical miles and not necessarily kilometers and stuff like that. So, and speed would be in knots, which is nautical miles per hour. Anybody know what a nautical mile is? If you take, because it's from latitude to latitude. It's the difference between them. It's a specific number. And I can't remember if it's 100 or 10 or whatever else it is. It's the number of units between your latitude lines divided. And it just didn't come out to be an exact mile. So, all right, we're good. I will see you on Thursday. I will have the practice test for the chapter 7 and 8 test up today. That's my goal when I go into the office today.
So the test on Alex, that's the practice test.
Yeah, you'll have a practice test for 7 and 8.
The real one.
No, that'll be the practice one. The real test will be the week after Thanksgiving. It'll be that Thursday.
Are we gonna do that on Thursday, the practice test?
No, we'll do it Tuesday after Thanksgiving. I have a few more things I got to cover on Thursday.
Does it do that? before?
Yeah, don't worry about the due dates.
So see what it says.
Yeah. Have a good day. You too. Start recording there.